In this video, I'd like to talk about parametric equations and plane curves. To start, I just want to think about some curves in the plane. And so maybe I can think of something, very simple, like y equals x squared, just a function. And we're probably fairly familiar with the squaring function and know that we generate from it this graph. And that's certainly a curve in the plane, and it seems reasonable that that's something I would call a plane curve. But not all curves I can draw in the plane can be described with a function. Maybe I have something more interesting, or at least mildly interesting, as a loop in it. That's certainly not a function. It fails the vertical line test. But it would still be nice to have some way to mathematically describe that kind of curve. And so here's a definition for us. Suppose t is a real number and it lives on some interval I. That interval could be any part of or even the whole real number line. T is just some number that lives on some interval. A plane curve is the set of ordered pairs x comma y, where x equals f of t and y equals g of t for t on that interval I. And so here's a set inclusion symbol. T is in I. So what I have here are two functions now. I plug in t to f and I get the x coordinate of a point. I plug in t to the function g, I get a y coordinate. So now it's like for every t, I pick a value of t, I get a point on this curve. And so the way I like to think about this is intuitively I can think about time going by. And maybe I'm traveling along this loop. And at every moment in time, I'm assigned to a point. So at this moment in time, I'm right here. And so I can kind of think about time starting and just kind of moving forward. And for every moment in time, I'm assigned to some point on that curve. These equations are what we refer to as parametric equations. So the equations x equals f of t and y equals g of t are called parametric equations. T is called the parameter. I like to think about t as time just to get an intuitive understanding, but it can be, many, many other things. The main idea here is that I pick a t, plug it into these functions, and I get a point on that plane curve. Well, here at the end of this video, I kind of thought we'd look at an example. So let's imagine that x is equal to t squared plus 1 and y is equal to 3t. And I'm told that t is between -2 and +2. Sketch the plane curve. All right, well, I'm gonna kind of do the laziest thing I know to do, almost the oldest thing I know to do. I'm gonna pick some values for t, plug them in those functions and see what happens. It's just now, instead of kind of picking x and getting a y, I'm picking a t and I'll get an x comma y. I'll get a point to plot. I'm just gonna get a grid ready. All right, let's see what happens. So I plug in a -2, and I get a 4 plus 1 is 5. I plug in a -2, I get -6. Plug in a -1, and I get a 2 comma -3. Plug in 0, 1 comma 0, 2 comma 3, and then finally 5 comma +6. All right, so now I have some points to plot, and we'll see what happens. All right, so 1, 2, 3, 4, 5, and now I need to go down to minus 6. Of course, I realize I haven't put enough tick marks on. 1, 2, 3, 4, 5, down to minus 6. All right, 2, minus 3. 1, 2, 3. 1, 0. 2, positive 3. And then finally, 5, 6. And I get a curve right here. Now, one thing we can do with parametric equations is we can indicate an orientation and increasing direction of the parameter. Meaning that as t increases, I was traveling along this way. All right, well, there are the basics of parametric equations and plane curves. Plane curves simply curve in the plane. Parametric equations can be used to generate them. That's it for now.